Hello, everybody. Adam Parks here with another episode of Receivables Roundtable. Today, I have an incredibly interesting guest. I have Mr. Jeff Shaffer, who is joining us from Recovery Decision Science. How you doing today, Jeff?
I'm doing great. Great to be here with you.
Awesome. Well, we really appreciate you participating. Jeff, I'm going to let him introduce himself, but I can tell you from my perspective, I learned something from every conversation with him as it relates to technology, deep learning, machine learning. And I wanted to share some of the things that I've learned through my conversations with Jeff with the rest of the industry, because I think it's something we all need to be talking about and learning from. But to kind of kick this off, Jeff, and just to kind of put you in perspective and your level of expertise, can you tell everybody a little bit about yourself and kind of how you got to the seat that you're in today?
Sure thing. Yeah, I'm the Chief Operating Officer for Unifund and Recovery Decision Science, and also the Vice President of Information Technology and Analytics. I've been with Unifund for 26 years now, and did a variety of roles. Started in the call center areas and building out the litigation unit with the attorney network. Did about 10 years running operations, then moved over to IT and analytics and did that for about 10 years, and have been running the company as the COO for the last 6 years or so. And bit of background, I guess, I don't think anybody comes out of college deciding that they're going to be in the collection world or in the debt buying world. But I was a musician in a former life, and before that, I had a lot of interest in technology, computers. And when I went to college, it was either going to be computers or music. In hindsight, maybe I should have taken computers, but always had an interest in computers and kind of did that along the way. So when I gave up the music career, I went back and got my MBA and studied just general business. And then after that, really started diving in with an interest in technology and analytics, and took a lot of classes and studied at the University of Cincinnati, a lot of the analytics courses, data mining and things like that. And that kind of led to where it is today, where I led the technology group and the analytics group, the data science team, and so on. So not your normal path, but fun nonetheless.
You're also, if I remember correctly, one of the highest levels of a Tableau's grandmaster.
Yeah, they call them Zen masters.
Zen
not
master.
a term I made up, but Tableau is a business intelligence platform. We use that at our company. It's our enterprise BI platform. I also teach it at the University of Cincinnati, where I teach data visualization and Tableau. And each year they select these Zen masters based on the community and so on. I think currently there's 43 in the world, and was inducted this year into one of 12 into the Tableau Zen Master Hall of Fame. So yeah, that's been a lot of fun. I love the tool and love data visualization, and it's a big part of what we do at Unifund and RDS.
Well, it's one of the reasons I was so excited to have you as part of this discussion, because again, I've learned so much about data visualization and data mining and those things through our conversations. And so that's where I wanted to make sure people kind of understood that background. Now, I know that you're with Unifund, and today our concentration is a little bit more talking about the Recovery Decision Science, or RDS, portion of that kind of family of companies. Can you tell us a little bit about RDS and what you guys do there?
Yeah, Recovery Decision Science was really born out of Unifund. It takes our technology, our analytics, our servicing, our master servicing, legal servicing, all of those things that are wrapped up, and that's done through RDS. So Unifund is really the debt buying company, and that is the company that still acquires portfolios from top issuers, but we do the same thing. We leverage the technology, processes, people, and the analytics specifically, and that's under the RDS umbrella. And so Recovery Decision Science can do anything from managing portfolios, master servicer or legal servicer for a creditor, which we do, or maybe just selling information as a product to them, like a suit decisioning score or real estate score or something like that, which we also do in the marketplace.
Okay, so you guys are doing both the service. So you're basically taking what you've learned at Unifund and applying it to another organization to where people can either acquire, customized data based on your data mining and other information technology, or you just service the accounts, on their behalf, which is pretty cool, right? Like to talk about economies of scope and kind of leveraging, the technology and infrastructure that you have in place to provide new and additional services. That's really cool.
Yeah, that's exactly right.
So I want to talk a little bit about data today, and kind of data mining and how that has changed, right? Because you said, like, as we've been talking about, like over the last, let's call it 10 to 15 years, like things have really changed from a data perspective. Can you tell us a little bit about how data management or data use has changed over the past decade or so?
Sure. In one simple form, you have size of data. Data is getting bigger with everything. They're tracking everything that we do, from our cell phone, location information, the apps that we're using, our financial information, anything that is done is all being tracked. And so in the public realm, that means things like real estate records and other public records are more readily available. And so data size and availability is bigger and a lot more available. The complexity of the data has changed, meaning a lot of unstructured data. It's not just rows and columns of simplified data, but you also have a lot of unstructured data. And we've been managing, I guess, unstructured data in our industry for a while. If you think about, collector notes or things like that might be entered into the system, a consumer fills out a field and writes a narrative or a complaint. But the way that we handle that unstructured data has definitely changed in the last 10 years with the advent of the things that we can do with technology and analytics, such as artificial intelligence, specifically machine learning and deep learning models that can do things that just frankly we couldn't do 10 or 15 years ago.
So, as we talk about the availability and complexity of data, and, we've talked a little bit about kind of the real estate piece, right? So you think about all of this real estate data that's available, from across our country, and what does that ultimately mean? I know one of the big challenges that I constantly hear about in our industry is how to take these massive data sets and actually extract some value. So, how do you extract value from these incredibly large data sets?
Yeah, that's a very interesting challenge. The first step, I guess, is you have to be able to digest that data. You have to be able to store it and use it.
Mhm.
And so that means you have to have a technology infrastructure to be able to onboard it, keep it secure if need be, and in many instances in our industry, that's paramount. So that's one challenge, right? We have data warehouses and massive data repositories that we handle on premise. There's also other tools that you can use to leverage to get the big data tools, if you will, that will help you leverage those things. And then once you digest it, then you have to figure out, okay, well, how do we use it? Like, how do we get it connected to our data, and how do we make it usable? And there's a lot of complexity into that. Something as simple as, well, real estate's a good example, because there's 330 million people in the US or whatever, and there's hundreds of millions of property records. Handling that really puts you at a position where you either have to outsource it to somebody who can, do it for you. You can buy information from, say, a LexisNexis or an RDS, and they can do those things for you. Or you have to have the ability to do that yourself and build that out, internally, which then goes back to that infrastructure, having the technology and available resources and staff and training to be able to handle that data and do something with that data. So yeah, that's the fun part for me. That's what our team really gets into at RDS.
Okay, so as we talk about kind of these, so now you've got this data and you've got it structured, and now you've got a place to hold it and kind of manipulate it. The next step is obviously kind of learning from it. Like, what do you see as the difference between AI, machine learning, and deep learning? Because these are terms that I think get just thrown out there regularly and intermingled, and don't necessarily, I don't know that people truly understand the difference between each one of those kind of methodologies. Can you help people understand that a little bit?
Certainly, for sure. It's really not as complex as it sounds. The complexity, I think, is in doing it and building it, but the terms themselves, I think, but part of the problem is that as they don't understand the terms, they get thrown out a lot in places where, as buzzwords, maybe.
Mhm.
Artificial intelligence, if you think about this as just a big circle or a big square, artificial intelligence is the big circle. And then a subset of that is machine learning inside of that circle. And then a subset of that is a smaller circle inside of that is deep learning. And
Okay.
so they're really subsets of each other, right? Artificial intelligence as a field is really trying to emulate the way that humans make decisions. And it's a way for us to automate that human decision. So in a broad sense, things that humans do. And there's things that we do better than computers, and there's things that computers do better than us, right? So a computer can add and subtract and multiply and do complex mathematics much, much faster than we can, right? That's why we use a calculator or a word processor or a spreadsheet. In the field of where humans are better, looking at something like our deep knowledge, for example, of images in our head. We know the difference between a basketball and a tennis ball and a volleyball because of years of experience in doing that. A computer doesn't have that experience and doesn't have that repository to pull from. And so the idea of things like machine learning is then the machine learning itself how to classify these things or to do these tasks in a way where you can train it. And this kind of goes into the idea of supervised or unsupervised, whether we tell the computer what to look for or whether we let the computer see what it can figure out on its own. And both of those are two different things. And then a level deeper is, no pun intended, deep learning is where we layer on these layers. Think of in your mind these neural networks that kind of connect your mind together. In computer terminology, when you have a neural network emulating the brain, it has these layers upon layers of, think, hierarchy, and that weighted hierarchy helps the computer decipher things and learn on its own. And so in a simple example, just to kind of bring this all home, it would be, imagine taking a database of just images of cats and images of dogs. If I want to teach a program to do that, I could teach it very specifically and say, cats have these whiskers and dogs don't, or cats have these pointed ears and dogs have floppy ears. But, then it's not going to be that simple because some dogs have straight ears and some dogs have floppy ears. And so then you have to go to these features of the image. And so you can train the computer and you can say, these are cats over and over and over again. This is a cat and this is a dog. And the computer will learn from your training model that these are cats or these are dogs. In an unsupervised model, we would just insert the image and just say, with a label, and the computer figures out those features themselves. These images are different from these images, and we don't even know why. The computer's figured out the ears and the nose and the eyes and the fur and the colors all on its own, but it sees a difference somehow between this set of images and those set of images. And so in simple terms, AI is really the mechanism for a computer to do something that a human being is good at, in teaching it to do it. Machine learning is a machine learning from its own experience and data mostly, right? You're giving it a whole bunch of data. That's a computer's experience because it doesn't live and breathe like we do. And then deep learning is layering on these layers, weighted layers, in a way that it can go much deeper into the analysis, into the features of things like image or speech or video or even data fields, and put that all together in a way that we can't. We're not going to be able to do that.
Very interesting. Honestly, that's the clearest explanation I've ever heard of those three different kind of layers, and that it is, a wider subset, a narrowed subset, and even narrower focal point. So I'm sure in building models that are kind of working through all really three stages of that, you're going to have some challenges in building those models and evaluating the disparate impact and kind of avoiding those situations in the black box, right? Because I can't imagine that you're building these incredible tools and being like, here, whole world, look under the hood, right? Like, because everybody's got their kind of proprietary way of doing things. And I'm sure that there's open source things as well. But, can you talk to me a little bit about some of those challenges and, what challenges you face in terms of building those types of models?
Yeah, well, let me talk to that black box a little bit, just because it's not just the proprietary nature of it that creates the black box. Like, I would call all of my algorithms at RDS proprietary in some form, right? Because we built them based on our own data, our own variables, and we did all that based on historical information, which is very proprietary to us. The difference, I guess, is where the black box comes into play is in when you're doing classic statistical methods on your variables. Let's just say I'm trying to figure out who should go in the litigation channel. We're going to make a suit decisioning score. And in that score, we have this idea that there's a probability that somebody's going to pay us. And then in another equation, maybe how much they're going to pay us. And that's how our suit decisioning score is defined. In that one equation, there's a whole bunch of variables that would tell us the probability that somebody's going to pay, how much they owe, or what state they live in, or do they have a job, or do they own a home? All these things that would tell you, yeah, there's a higher probability that that person will pay. And then in how much they'll pay, there's another set of variables. And again, might be the balance of their account certainly comes into play of how much they're going to pay. They're not going to pay you $30,000 if they only owe you $5,000. So all those variables come into play. In the classical statistical models, they are explainable, meaning that I can look at those variables. I can tell whether a variable has a positive weighting and it makes it better, or I can tell whether that variable has a negative weighting. We call those coefficients. If it has a positive coefficient, it will increase, say, the probability that it's going to pay. And if it had a negative coefficient, maybe it decreases that probability or how much they're going to pay. And in those linear logistic regressions, we can explain those variables. We can look at each variable and know what's important to the model, how important it is, and how it weighs in the weighting of importance in positive or negative respects. When you build these machine learning or deep learning engines, they're considered a black box because you dump in all these variables and you don't know how they interrelate to each other. You don't know how the computer is connecting this variable to this variable. And if the combined variable is a positive or a negative, how much it's weighting to the model. That is where the term the black box comes from, because at that point, you don't really know. Even if I wanted to explain it, I can't explain it as well as, say, a classical statistical method where I could look at the output and explain every variable. So then the next question,
like showing your math in high school.
Yeah, exactly. It's like, exactly, you're showing your answer. That's exactly right. You just got to the answer and you don't know how to show your work. And so that's the black box idea of it. And then becomes that question that you raised, which is, how do you then check for things like disparate impact analysis when you don't know the weighting of the variables? You know what variables you put in, so you can at least check that you're not using gender, a protected class of some sort. Sure. So of course you can do that, but you still don't know how they weight in there. And so what you do then, a couple different techniques you can apply to these black box things is you can look at the output of it. You can look at how it scored the output. You can look at the distribution of it. You can use, for example, there is a disparate impact code that the CFPB publishes. It's available on their GitHub page if you're interested in it. And you can run that code against your output, and you can say, okay, based on this disparate impact code that we're going to run, here's what your distribution looks like. And you can look at your distribution of your population as to start, and then you can look at the distribution of what you scored and what the output is, and you can make comparisons of that distribution. For example, if I only had 10% minorities in my total population, but my output is suing 100% of them, then my model is not good. It's proportionally suing, the protected class. And so that's how you can do checks and balances against these black boxes to make sure that you aren't you don't have a disparate impact on one, portion of the population versus another. And then, one final word that's interesting about all this is, we have found in many of our models that a lot of what we do ends up almost in reverse discrimination, because what happens is if you weight things like home ownership or jobs, just as an example. Well, if you look at the demographics in the country, who has, if you look at the unemployment rate, African Americans are, more unemployed than white Americans. Yeah. Home ownership is different. And so who has homes and jobs? White middle-aged men, that's who it is. And so your models almost, when you're at least looking at these models, they almost disproportionately move toward those kind of aspects, because you're looking at things like home ownership and jobs and income and other indicators that do that. So that's a little bit about how those models work and how we test against them.
That's great information. And you're right? Like your input is going to have, like, what you're putting into the model and what you're trying to evaluate may have some statistical factors in there that you can't control on the backside. But if you can look at the input and the output and kind of understand the variables that are going in and going out, that's probably an appropriate measure in terms of value there. Since I've only got you for a limited time today, I did have one other question that I wanted to kind of hone in on here, which is kind of, how are you guys applying the AI, the machine learning and deep learning specifically to this industry? Like, what kind of tools are you ultimately creating and making available to the industry?
Well, that's right on point. I'll give you a couple examples. Our litigation score is a good example. We have a version that uses the classical statistical methods, and we use that for many, many years at our company. And we have a number of clients who use that score today. So to decide which accounts, go in their litigation channel, that's an explainable model. Mm-hmm. It doesn't perform as well as the machine learning version of that model. The machine learning is more powerful and will be a better model. But if the explainable model is important, then we have an explainable version of the model. And if a machine learning model is okay, then we have a machine learning version of that model. The other big advancement is in our real estate. When we're looking at real estate, we used to look for home ownership. And what we've, over the years in the past, decade, all homes are not created equal, right? Just the fact that somebody owns a home does not mean they're going to have the ability to pay their bill. And so we've discovered, in our portfolios, a classic example is there's probably somebody renting in a very high value neighborhood at $2,000 or $3,000 a month, even, that is certainly better than somebody who owns a home that might be making a $400 mortgage payment. And so things like that kind of come into play that machine learning can do visually, from images of the property down to the neighborhood, looking at the image of the target property and the neighboring properties, and can score those in a way that we've never been able to score those before. It's kind of like in the advent of self-driving cars, right? We can do things that we just couldn't do 10 years ago. And so that's really how we're applying it in our world and for our clients, is propensity to pay models, suit decisioning, being able to get down to the granularity of the account and know more about that account, and being able to use it in a segmentation so that we're making better decisions ultimately.
So you guys are taking that beyond the, let's say, the Boolean logic of homeowner, not homeowner, and starting to apply specific values to homeowner, to the value of those homes, or the relative value of those homes to other homes in the portfolio or other homes in the neighborhood. That's a very interesting way to look at a common problem across the industry, right? Like, everybody who has a litigation model has some sort of home ownership associated to their score, but being able to take that to the next level and further weight your decisioning based on additional information that can be managed. But again, this goes back to where we kind of started here, and to bring this full circle, we talked about how to use these large data sets, and you guys are doing that in a creative way that is taking you beyond the Boolean logic and onto this much more sophisticated kind of weighted logic that can be used in making better decisions, which is why your statistically, your classic model versus your current and machine learned model are going to provide different results because they have different information or data sets available to them in order to drive decision making. It's really creative.
That's right. Yeah. And I would just add that what's also interesting is the things like real estate have gone beyond the litigation model, right? And even in voluntary collections and even upstream into the charge-off, pre-charge-off world, creditors are seeing value in things like the real estate score because it tells you something different, right? It tells you about, and I should clarify, we're not just giving a value of a house when you say the house is worth $300,000. It's a qualitative assessment of the condition of the house, right? Based on images. And so, something like that has broader impact, even than just, for litigation.
Incredible. I highly suggest that anybody who is interested in better understanding this information, I'll have Jeff tagged below as well as RDS on the whole so that you can reach out to their team and learn more about what it is that they have to offer. I've been blown away as I've had the opportunity to learn more about this and kind of see some of these scores in action. It's been really creative for me, and I'm a data nerd, right? Like I love technology and data, and being able to learn from somebody like you, Jeff, has really been a great experience for me. So I really appreciate the time that you spend with me. For those of you that are watching, if you have any additional questions that you'd like to ask, feel free to leave them in the comments below. We'll be answering questions on both YouTube and LinkedIn. If you have any additional topics that you'd like to see us discuss or guests that you'd like to see me interview, please leave those comments below as well. Jeff, I really appreciate you taking the time to chat with me again today. Like I said, I learned something from every conversation, and I'm definitely walking away from this discussion with a new way of seeing things.
It's been a pleasure. Thanks for having me.
Awesome. Thank you, everybody, for watching, and we'll talk to you again soon.